In the profound silence of the Chilean desert, a lone telescope stared into the abyss. And on the 1st of July, 2025, something stared back. It began as a mere speck of light, a phantom drifting against the fixed tapestry of the background stars. But this was no ordinary celestial wanderer. This was a messenger from the void. It was quickly designated 3I/Atlas, a clinical name for an object that would soon defy all clinical explanation. This was only the third confirmed interstellar visitor humanity had or conventional dusty traveler, 2I/Borisov, 2 years later. But this new arrival, this was different. Its velocity was staggering. It sliced through our solar system at a speed approaching 60 kilometers per second, far faster than any comet gravitationally bound to our own sun. Its trajectory was a perfect, sweeping hyperbola, a physicist's term for a one-way ticket. This object was not here to stay. It was a fleeting guest on an unending journey, destined to pass through our cosmic home once, and then never return. There would be no second chance, no opportunity to correct a measurement. Miss it now, and it would be gone from our skies forever. That alone would make it a monumental discovery. For this object is a physical fragment of another world, forged in the crucible of another star, perhaps billions of years ago. It is a time capsule from a place we can only imagine, delivered directly to our doorstep. But just as researchers believed they were beginning to grasp the nature of this visitor, they aimed the most powerful eye humanity has ever built towards it. And what the James Webb Space Telescope uncovered sent a tremor of alarm through the astronomical community. The rules, as we understood them, began to break. The chemistry, the very elemental signature of the object, matched no known model for a comet. The activity it displayed, the outgassing and faint glow, it simply should not exist under these conditions. The deeper scientists looked, the more profoundly uncomfortable the answers became. This was not just a rare comet. We're not looking at a rock, but at a relic. The object was expected to be a quick, strange, but ultimately understandable phenomenon. Instead, its behavior was an affront to our celestial mechanics. It raises the chilling prospect that we are not just missing a piece of the puzzle, but that we may be looking at the wrong puzzle entirely. This silent traveler from the interstellar dark is not just a discovery. It is a challenge to the very foundation of what we believe we know about the universe. It is a humbling reminder that in the grand, silent theater of the cosmos, we may not even understand the first act. There are certain sacrifices humanity is willing to make, monumental efforts of engineering and will, all to reach for the very edge of the universe. On the 6th of August, 2025, that edge came to us. When the James Webb Space Telescope fixed its golden, segmented eye toward the interstellar visitor designated 3I/Atlas, astronomers understood they were about to witness something profound. They believed they were prepared. They were not. This was no ordinary comet. It was a traveler from an unknown star system, a ghost that had journeyed through the interstellar dark for millions, perhaps billions of years. Using its near-infrared spectrograph, an instrument of almost preternatural sensitivity, Webb could perceive the universe in wavelengths of light utterly invisible to the human eye. It was designed to decode the chemical whispers of the cosmos, and the story it began to tell changed everything. The raw data that streamed back across 1 million miles of the first shockwave rippled through the scientific community as Webb analyzed the comet's coma, the ethereal halo of gas and dust bleeding from its frozen heart. The readings were so strange, so completely inverted from the norm, that teams scrambled to recalibrate, to double-check their instruments, convinced there had been an error. But there was no error. The data was unequivocal. Carbon dioxide. It dominated the comet's atmosphere in a way that was, to put it mildly, impossible. The ratio of carbon dioxide to water was approximately 8:1. Let that sink in. For every 1 molecule of water, there were 8 of carbon dioxide. This object was breathing out a gas we associate with the arid plains of Mars, not the life-giving vapor of Earth. Our own typically 10 parts water to 1 part carbon dioxide, or even higher. They are dirty cosmic snowballs. 3I Atlas, however, was something else entirely. It was a block of frozen primordial atmosphere. It completely and utterly reversed the pattern we thought was universal. And the deeper Webb peered, the stranger the story became. Alongside the overwhelming signature of carbon dioxide, it detected faint traces of other compounds. A whisper of water vapor, yes, but also carbon monoxide, ethanol sulfide, and even microscopic motes of dust and nickel suspended within the icy cloud. Each new reading was another piece of an impossible puzzle. Every single signal told the story of an object forged under conditions radically different from those that shaped our own planetary neighborhood. This was not just a foreign object. It was a messenger from an alien chemistry, a sample of a star system that may operate by a completely different set of rules. The implications were staggering. The comets of our solar system are cherished as frozen relics, pristine time capsules from the sun's chaotic infancy, and they are overwhelmingly defined by water ice. The sheer dominance of carbon dioxide in 3I Atlas suggests it was born in an environment we can barely imagine. Perhaps it formed in a brutally colder region of its parent star system, far beyond the frost line where water could condense. Or maybe it orbited a star with a fundamentally different chemical composition than our own sun. This wasn't just another icy rock. It was a fragment of a lost genesis, a world-building recipe that had preserved its secrets across an unimaginable gulf of time and space. And yet, even as scientists struggled to make sense of its composition, another mystery deepened with every frame. There was a peculiar lack of a conventional tail. No brilliant plume of dust, no torrent of outgassing vapor visible in the initial telemetry. The question that echoed through the control rooms was, what was pushing it? What unseen force was acting upon this silent traveler? Some theorized it was the gentle, persistent pressure of sunlight itself, acting on its dark, porous surface. A phantom force for a phantom object. With every calculation, Webb's data raised more questions than answers. How could a comet form with such an extreme, almost pure carbon dioxide core? Was its unique chemistry sculpted by the harsh radiation of its parent star? Or was it born in the absolute zero of a region far colder than our own Kuiper belt? This was just the beginning. The revelations from this single, fleeting visitor were not just rewriting our understanding of interstellar comets. They were forcing us to confront a far more profound truth: that the rules we thought governed the formation of worlds are perhaps not rules at all, but merely local customs. The universe, it seems, has more imagination than we do. The chemical fingerprint of the interstellar wanderer, 3I Atlas, was more than a mere curiosity. It was a whisper from a cosmos far stranger than we had imagined. Its very essence hinted at a story of origins not just beyond our solar system, but perhaps from a system that plays by an entirely different set of rules. The immediate question, the one that echoed through observatories and research labs, was profound in its simplicity. How does a comet come to be almost bursting with carbon dioxide, yet carry barely a trace of water? Data from the James Webb Space Telescope, our new eye on the universe, returned an unambiguous and startling answer. The ghostly shroud of vapor unfurling around it, its coma, was a breath composed almost entirely of carbon dioxide, 95% by mass. For astronomers accustomed to the water ice-dominated comets of our own cosmic neighborhood, this was fundamentally alien. The solution, scientists now believe, lies frozen in the darkness of its home system, countless light-years away. Such an extreme abundance of carbon dioxide suggests that 3I Atlas was born in a very specific VEBIT around its parent star, a region so cold that carbon dioxide gas free-crete and trap vastly more frozen CO2 than water ice, locking away the very unusual composition we witness today. It's a relic from a place where the building blocks of worlds are mixed in profoundly different proportions. But the story of its violent youth does not end there. Researchers suspect that before it was flung into the interstellar void, 3I Atlas was subjected to volatile sun, lashing out with torrents of charged particles, a stellar wind far more ferocious than our own. This cosmic bombardment would have scoured the comet's surface, altering its chemistry in subtle yet crucial ways, stripping away some molecules and forging others. It was effectively reshaped, its surface chemistry rewritten, before it even began its lonely pilgrimage across the galaxy. Every molecule, every grain of ice, therefore, becomes a clue. A forensic record of the conditions that existed billions of miles from our sun, in a time before it was cast out. When held against the familiar standard of comets from our own solar system, 3I Atlas is almost unrecognizable. Our typical comets are dirty snowballs, dominated by water ice and flecked with dust, and its head. It defies the intricate models that astronomers have spent decades refining. It is as if nature, in some distant corner of the Milky Way, was experimenting with a recipe entirely unknown to us. And 3I Atlas is the first precious sample of that experiment to have made its way to our doorstep. This single object forces us to confront much larger questions. If its chemistry is so radically different, what does that imply about the sheer diversity of planetary systems throughout our galaxy? Do other stars give birth to comets we would barely recognize? Comets made of materials we have yet to even consider? And more immediately, how will this strange, carbon dioxide-rich chemistry dictate the comet's behavior as it endures the growing warmth of our sun? Because the makeup of 3I Atlas is not just a static record of its distant birthplace, it is a dynamic engine, a clue to the next mystery. The unusual, and perhaps spectacular, ways it will react and outgas as its long, cold journey finally brings it face to face with a star. Each new observation is not just a glimpse of a foreign object, but a reflection of the infinite possibilities hidden in the dark. We look at it and see not just a comet, but a testament to the humbling truth that the universe is, and perhaps always will be, far more inventive than we are. Out in the silent dark, where the sun is a distant, indifferent star, it moved. A traveler between worlds, a refugee from a dead or dying solar system. Its name was 3I Atlas, and its very existence was a whisper of a reality where none should be. As this interstellar pilgrim continued its lonely journey through our cosmic neighborhood, astronomers watching from a world away began to notice something was profoundly wrong. Ultraviolet observations, piercing the darkness, revealed the unmistakable signature of water. An ethereal glow of hydroxyl emission, the ghost of water molecules torn apart by sunlight. This in itself was not unusual for a comet, but the location was. 3I Atlas was bleeding water vapor far, far from the sun, well beyond the orbital frost line where the warmth of our star normally begins to stir the frozen heart of a comet. At these extreme distances, comets are meant to be dormant relics, their icy surfaces locked in a deep, solid freeze, almost entirely inactive. And yet, this one was awake. The discovery was unsettling. The fact that 3I Atlas was showing signs of life so far out in the cold suggested a deeper, more complex process was at work beneath its alien surface. Scientists theorize that this visitor may carry enormous, slow-burning grains of ice, which release their water far more gradually than the fine dust of our native comets. Another possibility is that its crust is unusually fractured and active, constantly exposing fresh, volatile materials from its interior to the vacuum of space in ways that typical comets simply do not. This behavior confirms that 3I Atlas is not merely a chemical curiosity. Its premature activity demonstrates that it responds to solar heat and radiation in a fundamentally different way, a way dictated by the rules of a star system we have never seen. The outgassing patterns raised a cascade of new questions, not just about its chemical makeup, but about the very environment in which it was born. But the chemistry, as fascinating as it was only the beginning of the story. As 3I Atlas hurtled deeper into our system, ground-based telescopes began to pick up on yet another oddity, something that set this comet apart from anything humanity had ever witnessed before. They saw strange, shifting patterns in its coma, the vast cloud of gas and dust that shrouded its nucleus. Instead of a simple, elegant tail streaming obediently away from the sun, 3I Atlas displayed wobbling, wheeling jets of material that seemed to twist and turn with a mind of their own. And then came the truly bizarre observation. On rare occasions, astronomers detected faint structures pointing in the wrong direction. Antitails, with delicate streams of dust aimed almost directly toward the sun. This, on its face, violates the basic physics of the solar system. The constant, gentle pressure of sunlight, the solar wind, pushes dust and gas away from a star. It is the fundamental reason a comet's tail always points away from the sun. While an antitail can sometimes appear as a trick of perspective, a geometric illusion when Earth crosses a comet's orbital plane, the structure seen in 3I Atlas hinted at something more. They suggested complex, violent, and utterly alien internal dynamics. Scientists realized, with a growing sense of awe and confusion, that these unusual jets challenged everything they thought they knew about how comets work. This visitor was not just a piece of rock and ice. It was a puzzle box, sent from an unknown corner of the galaxy, whose every strange behavior was another clue, rewriting our understanding of what is possible in the cosmos. In the silent, predictable clockwork of our solar system, comets obey a certain set of laws. They are travelers bound by a simple covenant with our star. As they fall inward from the frozen dark, the sun's warmth awakens them. Ice, locked away for eons, transforms directly into gas, a process of gentle sublimation that lifts dust from the surface. These streams of gas and dust are pushed back by the solar wind, forming a magnificent, iconic tail that always, without fail, points away from the sun. It is a fundamental rule. a cosmic weather vane showing the direction of celestial winds. But then, from the unimaginable gulf between the stars, came a ghost, a visitor named 3I Atlas, and it was breaking the rules. This was not a member of our celestial family. It was an exile, a messenger from another star system, carrying with it the chemistry of a place unknown. And as it drew nearer, astronomers watched in disbelief. Its jets of gas and dust, the very plumes that should have been streaming obediently away from the sun, were bending. Some were twisting back, curving defiantly toward the inferno they were meant to flee. It was a celestial act of heresy, suggesting complex internal forces, a rotational spin so alien that even the most seasoned comet watchers could not immediately decipher its meaning. This object was not just a passive, frozen rock being weathered by the sun. It was alive with processes that were either entirely new to science or operating at a level of intensity far beyond anything native to our own cosmic neighborhood. Every observation only deepened the enigma. Each subtle wobble and twist in its outgassing jets became a hieroglyph waiting to be translated. They hinted at a world of profound complexity hidden beneath its surface. Patches of unique minerals, uneven pockets of ice heating at different rates, or perhaps even cavernous internal structures channeling the violent explosions of gas and dust in these bizarre, unexpected directions. The presence of so-called antitails was particularly revealing. These were not tails at all, but faint, sunward-pointing fans of dust. They suggested that larger, heavier dust particles were not simply being blown off the surface, but were being ejected with such force and geometry that their own momentum briefly defied the power of the sun. This was not a simple snowball. This was a dynamic, evolving world, a puzzle box tumbling through our skies. And the key to unlocking it lay in its very breath. The chemical composition of Oumuamua comets are mostly water ice, dirty snowballs slowly melting. This interstellar pilgrim was more akin to a block of cosmic dry ice. Carbon dioxide sublimates at far lower temperatures and with much greater ferocity. This exotic chemistry could be driving the outgassing in ways we had never witnessed, creating pressures and jets that behaved according to a different set of physical principles. It was a direct challenge to our most basic understanding of how comets form and evolve across the galaxy. To capture this fleeting visitor, humanity turned its most powerful eyes toward it. The venerable Hubble Space Telescope, our steadfast eye in the sky for decades, delivered breathtakingly sharp images. They revealed the fine, ethereal structure of the comet's coma, the glowing atmosphere of dust and gas surrounding its core, and traced the intricate architecture of its plumes. Then, the James Webb Space Telescope, a technological marvel, peered into the infrared, sensing the heat and chemical fingerprints invisible to other instruments. Together, they painted a portrait of an object of startling order. The jets, for all their strange behavior, displayed a persistent geometry, a near-perfect symmetry that spoke not of chaos, but of a deeply ordered, if alien, internal engine. Story. It is a physical artifact from a solar system that may be billions of miles and millions of years away, a place we will never see. Its bizarre dance with our sun tells us that the universe is more varied, more complex, and perhaps more strange than we have ever allowed ourselves to imagine. It reminds us that our own solar system, with its familiar rules and predictable orbits, may not be the standard, but merely one quiet, local exception in an infinitely diverse cosmos. It drifts through the black, a phantom wrapped in its own breath. At its center, an icy core, a relic from a star system we will never see. But this heart is veiled, surrounded by a vast, ethereal cloud of gas and dust. It's Coma. To gaze upon this object, this interstellar wanderer, designated 3I/Atlas, is to confront a profound challenge. How do you measure something that refuses to be seen? Estimating its size became an exercise in scientific frustration. The coma, diffuse and glowing, acts as a shroud, making any direct measurement of the nucleus within a near impossibility. Based on the faint, scattered light and complex models of its dust, scientists offered a guess. Its diameter, they proposed, lay somewhere between 320 meters and 5.6 kilometers. That chasm of uncertainty is, in itself, a testament to the comet's alien nature. The nucleus, its true heart, remained stubbornly, frustratingly, hidden. Our conventional methods, the tools we use to size up comets born in our own solar system, began to fail. We estimate size from brightness, a simple enough principle, but here the standard models proved unreliable. The dust possessed unusual properties, scattering light in ways we didn't expect. And then there was the outgassing, an extreme, violent expulsion of carbon dioxide that warped every calculation. Even so, the smallest estimate makes it a substantial object, a cosmic iceberg capable of carrying an enormous cargo of frozen material across the silent gulf between stars. Every new measurement, every failed model was another clue, another whisper of its origin and the bizarre conditions it must have endured before finding its way to us. To pierce the veil, it would take more than one pair of eyes. It required the combined power of humanity's two greatest observatories. The Hubble Space Telescope, with its razor-sharp visual imaging, was tasked with charting the physical world, the intricate structures of the dust, the ghostly jets erupting from the unseen core. But to understand its soul, we needed a different kind of sight. The James Webb Space Telescope turned its infrared senses upon the comet, tasting the chemical makeup of the coma itself. What Webb found was astonishing. It revealed a composition dominated not by water, the lifeblood of our own system's comets, but by carbon dioxide. It was a chemical fingerprint from a place unimaginably different from our own, with faint traces of other exotic compounds we are still working to identify. Hubble, meanwhile, provided the context, a detailed map of the dust streams and the strange, wobbling jets that had puzzled researchers for months. Together, the two datasets painted a picture neither could have achieved alone. For the first time, scientists could see how the alien chemistry of the nucleus was interacting with the dust surrounding it. They could finally understand the engine driving the strange patterns, the sputtering and unpredictable activity. These composite observations are so much more than just pictures. They are a window into the comet's very being, offering a glimpse of the internal processes, the chaotic physics and chemistry that animate this visitor. And yet, even with these incredible images, the comet remains a wild, unpredictable thing. The data, it seems, raises as many questions as it answers. Visuals alone cannot tell the whole story. The numbers, the cold, hard data behind 3I/Atlas, from its extreme velocity to its peculiar chemical ratios, reveal a hat these numbers mean. To do so could rewrite everything we thought we knew about comets, about interstellar objects, and about the sheer diversity of planetary systems scattered across the galaxy. We cannot truly pinpoint the size of that nucleus, not just because of its scale, but because its own furious activity actively works to conceal it. This object defies expectations at every turn. Its activity rates tell a story of immense power. The sheer output indicate that every second, it loses approximately 130 kilograms of carbon dioxide. In that same second, it releases only about 6.6 kilograms of water. An extreme, almost unbelievable imbalance. For every quiet whisper of water, a roaring torrent of carbon dioxide. It is a messenger, carrying a story written in a chemical language we are only just beginning to decipher. A single, fleeting visitor, here for a moment and then gone forever, forcing us to admit how little we truly know about the endless variety of worlds that drift in the great, silent dark. Its very breath betrays its origins. Where comets born of our own sun exhale a familiar veil of water vapor, this traveler breathes a choking plume of carbon dioxide. This heavy outgassing, so profoundly atypical, is the first clue that the comet known as 3I/Atlas was forged in a crucible vastly different from our own. A place where the fundamental rules of planetary creation may have been rewritten. And the materials locked within its frozen heart are just as intriguing. As our instruments peer through the cosmic dust, they detect the faintest traces of nickel and exotic sulfur compounds, hinting at a chemical diversity that feels utterly alien. These are not the building blocks we know. They suggest the comet's parent star, now a nameless point of light in the abyss, presided over a system with a radically different chemistry. 3I/Atlas has carried this primordial fingerprint, this chemical dialect, perfectly intact across unimaginable gulfs of space and time. Every molecule, every grain of dust adds another layer to the enigma, offering a rare and precious insight into how worlds beyond our own might form, evolve, and perhaps die. When the numbers are this strange, it is easy for the mind to wander into the wilder territories of speculation. Some have looked at the data and whispered a forbidden question. Could 3I/Atlas be an artifact, a probe, or the result of some cosmic phenomenon for which we have no name? The scientific community, however, approaches this ghost from another star with a deliberate, almost reverential caution. They meticulously dissect every anomaly, every deviation from the norm, focusing first and foremost on the natural explanations. Yet, they do so while acknowledging that this interstellar visitor continues to challenge the very bedrock of what they thought they knew about these celestial wanderers. This object, 3I/Atlas, is so much more than a fast-moving chunk of ice and rock. Its extreme velocity, its bizarre exhalation of gas, and its unique chemical signature make it a messenger, a sealed letter delivered from an unknown sender. It was the very first object of its kind ever discovered to have originated from outside our solar system, a true immigrant from the stars. The sheer strangeness of the initial observations prompted astronomers to act. In a move that blurred the line between science and science fiction, one of humanity's great ears was turned to listen. The silent, sweeping dish of the Green Bank telescope strained to catch a whisper of a technosignature, any coherent signal that might betray an artificial mind at war. So far, the silence from the stars has been absolute. there has been no evidence of alien transmissions. No rhythmic blinking lights, no hidden messages encoded in the static. For now, the comet remains a marvel of nature, not of engineering. Yet even with this lack of artificial interference, a profound sense of caution remains. Researchers stress that while 3I/Atlas behaves in ways we have never witnessed before, every single observation can, in theory, be explained by natural processes. Its extreme carbon dioxide output, its wobbling, unpredictable jets, and its erratic patterns of outgassing could all fit into complex scenarios. Perhaps it has a chaotic, tumbling rotation, causing it to heat unevenly. Or perhaps its interior is a volatile chemical engine, sputtering to life after an eon of deep sleep in the interstellar dark. They are careful not to leap to conclusions, studying this cosmic enigma with an open mind, letting the cold, hard data be their only guide. It is a testament to the discipline of science, to resist the allure of a simple, extraordinary answer in favor of a complex, natural truth. This comet is a reminder that the galaxy is not a sterile, uniform expanse. It is a vibrant, varied, and chaotic place. Understanding the numbers, the speed, the chemistry, the behavior, may not only explain this single object, but offer us a rare glimpse into the breathtaking complexity of creation. It tells us that our solar system is not the only template, that other suns may give rise to worlds and wanderers that defy our every expectation. It reminds us that the universe has more imagination than we do, and that the greatest discoveries are often not the answers we seek, but the questions we had never thought to ask. In the grand, silent theater of the cosmos, a new actor took the stage. Community to this day, for the interstellar comet known as 3I/Atlas, fundamentally challenges our models of what a comet should be. Within the familiar confines of our own solar system, we have come to know comets as predictable wanderers. They are, for the most part, great spheres of ice and rock, rich with frozen water. When they stray too close to the sun, its warmth coaxes them into life, producing the glorious, predictable tails and outgassing jets that have captivated humanity for millennia. They are our sea. But this visitor, this phantom from another star, behaves differently at every turn. Its very chemistry is an affront to our expectations. The extreme dominance of carbon dioxide in its composition suggests it was born in an environment profoundly different from our own. A place far colder, perhaps, in the frigid outer reaches of a star system we will never see. And then there are its jets. Instead of being pushed away by the solar wind, some of its plumes of gas and dust were observed bending toward the sun, a baffling display that hints at complex, unseen internal dynamics. A tumbling, uneven nucleus spinning in ways we can scarcely model. No comet born in our own cosmic neighborhood has ever displayed such a confounding combination of features. It makes 3I/Atlas both a source of immense fascination and profound frustration. Scientists now weigh every photon of light, every spectral line, as if it were a sacred text. They run simulations on supercomputers, attempting to birth a digital ghost of the comet that behaves as the real one did. They compare it, meticulously, to Oumuamua and 2I/Borisov, the only other confirmed travelers from beyond our sun's grasp. Oumuamua was the bizarre, tumbling enigma. 2I/Borisov, a more reassuringly conventional, if alien, comet. 3I/Atlas is the third messenger, and perhaps the most perplexing of all. Each new analysis narrows the field of possibilities, Yet its most unusual features keep the discussion fiercely alive. Even with all the data in hand, the object remains a beautiful, unsettling mystery. By late 2025, the moment of truth had arrived. 3I/Atlas reached its perihelion, its closest approach to both the Earth and the Sun. It was a fleeting encounter, a breathtakingly brief window when the astronomers of Earth could study this ghost up close, before it was flung back out into the interstellar dark from which it came. At its brightest, the comet was a faint smudge visible through a range of telescopes, a once-in-a-lifetime opportunity to capture data that might never be obtainable again. The pressure was immense. Every observation was precious, for once it passed beyond our reach, 3I/Atlas would be gone forever, leaving behind only the questions it had raised. A global mobilization began, a coordinated effort of unprecedented scale. Ground-based observatories from Chile to Hawaii, S-point of light. Every piece of information mattered. High-resolution images to map its nucleus, chemical analysis of its vaporous coma, measurements of the dust it shed into space. It was a race against time in the truest sense. The comet's extreme velocity meant the window to study its composition was brutally short. Researchers had to act fast, making split-second decisions on which instruments to use, which aspects of the comet to prioritize. The universe, it seems, was dictating the schedule. Some teams even proposed more ambitious, almost desperate efforts, last-ditch attempts to learn just one more secret before it was too late. And then it was gone. Vanished back into the depths. We are left with its legacy, a trail of light on a photographic plate, and a deep, resonant ambiguity. It serves as a stark reminder that our solar system is not the universal blueprint. Out there, in the darkness between the stars, are countless other worlds, forged by it called home, or the journey it took to reach us. We are left only with the echo of its passage, a whisper that the cosmos is, and will always be, more strange and wonderful than we can possibly imagine. In the hushed corridors of space agencies and the buzzing forums of astronomical communities, a radical, almost impossible notion began to circulate. It was a proposal born of equal parts desperation and genius. To launch a spacecraft on an intercept course, to thread a needle through the vastness of space and fly directly through the tail of the interstellar visitor. The goal was audacious: to physically capture the dust and gas streaming from this alien artifact, to bring a piece of another solar system back to Earth. Such a mission would have been without precedent, a cosmic chase to sample the primordial building blocks from a star we may never even see. But the universe is indifferent to human ambition. The time constraints were brutal, almost absolute. This object, 3I/Atlas, was not on a G at a velocity that defied our conventional mission planning. To design, build, and launch a probe, to navigate the intricate gravitational dance required for a rendezvous, and to collect a sample from an object that would be in our neighborhood for a mere matter of months? It was an engineering feat teetering on the edge of science fiction. The logistics were a nightmare, a high-stakes calculation against a clock that was already running out. And yet, the very fact that such plans were seriously considered, that engineers and physicists stayed up through the night running simulations, speaks volumes about the significance of this fleeting encounter. Every observation from the ground, every precious measurement of its trajectory, every calculation of its speed, added another brushstroke to the portrait of this enigmatic traveler. Scientists were not merely tracking a celestial body. They were listening to a messenger, a silent courier carrying a story written in ice and dust, a story from a place of unimaginable distance. Its transient presence demanded everything we had: our sharpest focus, our most precise instruments, and a speed of thought to match its own journey through our skies. Now, as it recedes, disappearing back into the silent black expanse from which it came, its physical presence is lost to us. But the data, the faint light captured during its brief, spectacular visit, will be a source of revelation for decades. 3i Atlas was more than an object of curiosity. It was a rare and precious gift, an opportunity to learn how comets are born around other stars, to see how materials forged in an alien crucible behave under the light of our own sun, and ultimately, to ask what its existence reveals about our own place in the cosmos. Its visit has already begun to fundamentally alter the way we perceive the universe. The comet's chemical signature was, to put it mildly, a shock. Its overwhelming dominance of carbon dioxide gas flew in the face of everything we thought we knew. For generations, astronomers had worked under the quiet assumption that comets, whether from our system or another, shared a broadly similar composition. The physics that form them, we believed, were consistent. This interstellar visitor completely dismantled that assumption. It served as a stark, beautiful reminder that the galaxy is profoundly more varied, more creative than our models had ever allowed. It proved that other stars can give rise to worlds and objects with properties we have not yet even begun to imagine. The implications for the science of comets are simply enormous. If they are not uniform, then each one is a unique time capsule, a window into the specific environment of its birther. Perhaps there are comets rich in methane or ammonia or compounds we have yet to discover. Each variation carries the spectral signature of its home system, a chemical fingerprint that speaks of the temperatures, the radiation, and the raw ingredients present at its creation. The race to study this particular messenger may be over, but the lessons it carried across the interstellar void are only now, slowly, beginning to be understood. It is, in essence, a physical record of another star system's history, an archive of information that could never be gleaned from the faint light gathered by our telescopes, nor from the familiar comets born in our own celestial backyard. Within the visitor known as 3i/Atlas, every single molecule, every grain of exotic ice, holds a clue to the physics and chemistry at play millions, or even billions of miles from our sun. It is a frozen message from a place we will never see. Beyond its chemical composition, this traveler offers a rare, fleeting chance to witness how an alien object truly behaves within the intricate clockwork of our solar system. Its chaotic, wobbling jets of gas, its strange and ghostly antitails pointing toward the sun, the unusual way it outgassed its ancient materials, all of it revealed processes that fundamentally challenge our existing models. Experts are now coming to a profound realization that interstellar comets may be far more dynamic, more violent than anything we have ever witnessed before. By observing how 3i/Atlas responded to the unblinking glare of our sun, to the subtle pull of our planets, and to the constant stream of solar radiation, we refine our understanding of all comets. But more than that, we begin to reshape our very conception of how materials, the building blocks of worlds, can traverse the unimaginable voids of interstellar space. Every one of these visitors is a direct, tangible sample from another star. That makes them tiny cosmic treasure chests, filled with priceless information about how other planetary systems form, evolve, and perhaps die. Studying them allows astronomers to hold our solar system up to a galactic mirror, giving us, for the first time, a sense of what is typical and what is truly, uniquely our own. 3I/Atlas proves that even the smallest, most transient objects can carry enormous scientific weight, bridging the silent, lonely gap between distant stars and our own planetary home. Its passage, of course, ignites far bigger questions. How many other alien comets, how many silent messengers have passed through our system completely unnoticed? What other chemical or physical surprises await us in the vast, dark stretches of the galaxy? As 3I/Atlas recedes once more into the blackness, it leaves behind not just data, but humbling lessons about diversity, complexity, and the sheer, beautiful unpredictability of the cosmos. It is a reminder that the universe is alive with a variety we are only just beginning to comprehend. A galaxy not just of stars, but of stories, waiting to be discovered.